Chemsters, this is Mrs. Vanderlei bringing you OChemster video. All right, so yesterday we were introduced to the nucleophilic substitution reactions, and we left off here, so I thought I'd go over problem number 5 and go on to the next page with you today. So what we learned yesterday is that in a nucleophilic substitution reaction, we have the nucleophile, which loves that positive or the partial positive of that alkane group. And then we have a substrate, which has the halide on it, and the halide is your leaving group, and then you have your desired product. This is really an important type of reaction because we can custom make our products using this. So if we have a desired product, let's say in medicine or something, that you can use this nucleophilic substitution to create that desired product. And so that's what this problem number 5 is all about. Is like, this is my desired product, this is what I really want. How do I make this? Okay, so let's start with the first one. I think we may have done this in class. So here is my desired product, okay? And you know we're always going to have a leaving group, right? And so I made that in green. So now the questions are, what are my two reactants that give me this butanol, right? So I have the 4 carbon with the OH group at the end, so it's your butanol. Well, what's my nucleophile? Well, look at the end here. This is my non-alkane, if you will. This is my my desired, part of my product here, the OH group, the alcohol. So what's going to give me an alcohol? Well, it has to have an OH in it, right? So the question is, what will be the charge of my nucleophile? If this is neutral, what did we say yesterday? That the nucleophile must be negative. If we have a neutral product, then my nucleophile must be negative. So then what will be my substrate? My substrate has, excuse me, the bromine, the leaving group in it, and I'm sorry. There we go. So my substrate has to have my leaving group in it for my hydroxide to swap with the bromine. The bromine leaves, the hydroxide joins. So let me kind of clarify something just to make sure you know this. If your OH group is actually attached to the carbon, then it's an alcohol. If the OH group is not attached to carbon, if it's by itself, or if it's with an ion, a cation, then it's a hydroxide. So you only call the OH an alcohol when it's actually attached to the carbon. So anyway, the OH is my nucleophile. Where the bromine is, bromine leaves, and the hydroxide comes in. So does this all make sense? I have a negative and a neutral, making a neutral and a negative. The charges work out great. So what about the next one? Well, this is my desired product. And I'm going to have a leaving group. By the way, I'm going to color code everything so I don't have to write leaving group. So greens are going to forever be my leaving group. The blues are going to be my substrate. And my reds are going to be my nucleophile. So what is my nucleophile here? Well, this ending part looks kind of interesting here. It's my cyanide. And what is my charge of my product? It is neutral. So what must be the charge of my nucleophile? Must be negative, and there's your cyanide ion. So once again, where the cyanide goes, that's where the bromine is going to start out as, but it's going to leave, and the cyanide is going to come in and take its place. Now in letter C, please make this change for me. I think you have a typo. At least I had a typo in mine. I don't know if I fixed it on yours, but please make it so it looks like what I have here. How did I know there's a typo? When I looked at it, one of two things. If nitrogen has 3 bonds, it's neutral. If nitrogen has 4 bonds, it's a positive charge. Okay, so that's how I knew that there was an issue here. Okay, so I'll say it again. In order for nitrogen to have a positive charge, it has to have 4 bonds. Well, there's 3 groups hanging off of the nitrogen plus a hydrogen. That's going to be your positive compound then, okay? So if nitrogen has 4 bonds. So this is my desired product. I'm going to have a leaving group. So then what can I have in order for this to work, all right? Well, I'm going to look at my leaving group first, all right? My organic product. It's going to have the bromide here. So I used one of the groups here, making this one with my 2 groups. Okay, so here this has 2 of the propyls. Here I have 1 more propyls. They're going to come together to make 3 propyls and still have the H here. So what else do you know is that this has a neutral nucleophile, correct? If I have a neutral nucleophile, then this is going to be positive. Okay, hopefully that makes sense still. Okay, let's go on to the next one. Okay, I'm not sure if you have a typo in here, but again, for the same reason, for nitrogen, sulfur will be a positive charge if it has 3 bonds on it. So if yours didn't have a 3 on there already, put it there. So this is my, this is my organic product. And the bromine is, chilling out here. So in a sense, I separated the plus and the bromide minus. So this is really what we're looking for. Okay, so there once again is my leaving group. Just like the one with nitrogen above, I kind of did the same thing. So if my desired product has 3 of these propyl groups off the sulfur, I'm going to make this here is my substrate with my leaving group that has 1 of those propyl groups. So my nucleophile with the sulfur here, oopsies, come on up, all right, is going to be my nucleophile. Let me show you something. So I'm on the previous page under the sulfur, and I am right here. Do you see it says R2S? R is any carbon group. So my nucleophile can have any carbons, 2 carbons hanging on the sulfur, and notice that I end up with my positively charged ion here with 3 carbon groups on the sulfur. So I'm applying this right here to that product here. Okay, don't worry, you're not going to have to name it. Isn't that a good thought? Let's go back to where we were. So once again, here's my sulfur with 2 R groups. Okay, I chose the exact same R, if you will, so I can end up with 3 of the identical R groups. All right, what if I only wanted 1 carbon to be attached, and I'd make 1 carbon here? Okay, but that's not what the problem asked. So here I have this, and okay, here is my desired product, and I'm going to have a leaving group. So once again, this is a neutral compound, isn't it? So my nucleophile has to be negative, and it's an I value. If you look at that page I was just at the very bottom, iodine can be a nucleophile. So then what is my substrate? My substrate is everything here minus the I put the Br in its place. Okay. And is this the last one? I think it's the last one. So here I have this is actually an organic ether, and I'll just scroll down a little more. And so this is my desired product. I'm going to have a leaving group. So it's this OCH3 is my nucleophile. Notice that this is a negatively charged, and this is neutral. And so my bromine is this side of it, the left-hand side of the O, because the bromine goes out, the oxygen and the carbon go in its place, okay? So these are just practice of these certain kinds of swap, all right? Where the bromine goes out, the nucleophile comes in, just like when we talked about swaps before. Let's go on to the next page. So I couldn't recall if we actually went over something like this. We may have skipped this idea back when we were working with the alkanes and alkenes and alkynes, that kind of stuff. So last chapter, no, 2 chapters ago. So it says, show 1 butane can be converted to making 3 hexane using this nucleophilic substitution reaction. I think I spelled substitution wrong. Anyway, what we had to do is somehow make this 1 butane into an ion, an anion, a negatively charged ion, so it could be my nucleophile. Why would I want that? Because, well, in order to have a neutral 3-hexane, which this is, I needed to have a negative ion to be my nucleophile. If this is neutral, a nucleophile has to be negative. So back when we talked about alkynes, again, I may have skipped this. If you use sodium, what would that be? I can't remember. Sodium something. That it will strip off the H over here. It will strip off your first H. So notice I accomplished that. So with my sodium, whatever, I stripped off my my hydrogen. Notice there's no hydrogen at the end, making it a negative. and then I can put it right here. The bromine goes out, this thing comes in, and there's my 3-hexane. So before you panic, no, it's not going to be on your test. Or if I didn't teach you this step here, then no, I'm not going to ask you to do it again, okay? So there's a limitation of R. This works great for your alkanes, which means your alkyl halide, all right? So you're single bonded. So if you have, you know, here, this is my single bonded alkane, okay? Looking at my R group off of the bromine, okay? Now the problem is it does not work very well for alkenes, which would be called a vinyl halide. Remember, vinyl is your branch that has a C double bond C, and your aromatics, and then your if you have an aromatic that is a branch, we call them aryl, so aryl halide. So it doesn't work well for anything that has an sp2. So that would be your R. What's your R? Right here, the one that's with the bromine. That is where you have limitations. So it doesn't work for everything. Now, if your nucleophile is either an anion or a base or both. So look what's happening here. I'm going to show you 4 situations here, which is going to lead us up into the next couple sections. So if I have a cyanide, which we know is an anion, and I have a primary. Why is it called primary? Because here, this carbon right here is bonded with 1 carbon, the bromine, and 2 hydrogens. All right, it's not branched. So the carbon next to the bromine is what you're looking at. There's no branches hanging off of this carbon, so it's a primary, and we get exactly what we had said before. All right, so that should not be a shock. But look what happens if I have the exact same setup with a cyanide, but now the carbon that the bromine is attached to has branches, has this methyl group on that carbon as well. This is what's called a tertiary because it has 1, 2, 3 groups hanging off of it, all right? And there's no hydrogens hanging off of this carbon. So look what happens. You don't make a nice normal change. Something odd happens. We make a double bond. The H that came off of one of these end carbons between the middle one and the end, one of these H's came off. I guess it was the one over here on the left. Came off, bonded with the cyanide, and the bromine is still a leaving group. So my nucleophile does not attach itself to the substrate. Huh, isn't that interesting? Let's see another example. All right, here I have water, neutral water, and I have a primary, excuse me, a tertiary, again, same as above, but now I have neutral water. I don't make a double bond. The OH comes on, and the H from the water, the next H, the second H, goes with the bromine. Isn't that odd? And finally, look what happens here. I have this branch with the OH again. I have the double bond water and bromide. Isn't that interesting? So there is something coming up that we're going to be talking about, and that's where we start talking about SN1, SN2, E1, and E2. All right, so that's what the rest of this chapter is going to be about. So hang on to your hats, and I'm going to quit right here and follow Google Classroom to see what you have to do next. Thanks. Have a good day. Bye-bye.